Okay, a report stated that the average number of times a cat returns to its food bowl during the day is 15. So that's the average is 15. Assume the standard variable is normally distributed with standard deviation 2. Obviously, that's standard deviation. What is probability a car would return to his dish? A cat would return to his dish more than 16 times a day. Um, Nowhere does it refer to being standard normal. There's no z given, so we have to calculate the z. Number z is equal to x minus mean over the standard deviation. X. If I get back there, there we go. X is going to be the part that goes with your probability or percentage, which is a 16. Not to mention the other ones tell you their mean and standard deviation. So this one says it's the average, the 15. This other number, the 2, says it's the standard deviation. Usually those are pretty obvious. I can actually do this one in my head, which I made up the numbers, so that's not surprising. I chose nice numbers. 16 minus 15 is 1. 1 divided by 2 would give us 0.5. Now let's go back and read our problem. It says, what is probably a cat would return to his dish more than 16 times? More than is greater than. So it'd look like this. Now our table is based upon the area of the left. So whenever you have it shaded to the right, you immediately want to rewrite it as 1 minus shaded to the left. Now I'm going to go look up the 0.5 in my table. Now remember, if you don't have the hundredths place, there's a default 0 there. This is my first part of my number, and this is going to be my hundredths place, so that'll be 0.00. So first part of my number, 0.5, I'll locate that on the left side. My hundredths place is 0.00. And the intersection of those is going to be my value. So I'm going to have 1 minus 0.6915. And I'm not very good with decimals. Equals 1 minus 0.6915 gives us 0.3085. If you're putting that in percent form, you'd move your decimal point 2 places to the right and then round as appropriate. Always round at the end.